So I don't know if any of you guys have been down to the Dolphin Island Sea Lab. I know there's a bunch of people from UAB that come down in the summer and take marine science classes down there. So if you haven't and you have the opportunity to, I definitely recommend it. You get to live on an island for a summer, so. And they have a really good cook. So again, my name is Caitlin Wessel. I work for NOAA's Marine Debris Program, and I'm a scientist there, and I work on prevention, removal, and research, all things marine debris along the Gulf Coast. And I'm going to talk a lot more about marine debris in just a second, but I wanted to talk to you first a little bit about how I ended up here. So I first moved to Alabama in 2013 to start a PhD at the University of South Alabama. Like she said, I was originally doing restoration work. I thought I was going to do work on seagrasses and in marshes, looking at ways to better restore those environments. But once I got out there, we were taking samples and we kept coming up with all these plastics that were in our samples, and you have to sort all the plastics out of your cores before you could process them, and it was a giant pain in the butt. And one thing led to another because I couldn't figure out why there were all this plastic in these seagrasses. It's not like we're throwing all of our plastic in seagrass beds. And so one thing led to another, and I ended up changing my PhD focus from restoration work to just straight marine debris work. And so I'm sure you guys have seen lots of stuff recently in the news about marine debris and plastics in the ocean and microplastics coming from your clothing and off yoga pants. And so it's been all over the news lately, but it's also been all over the research arena lately. And the research on both marine debris and microplastics has really exploded in the last 5 to 10 years. I wanted to point out these real quickly. So I've done a bunch of sampling that I'm going to talk about later, looking at these microscopic plastics. And so this is a bunch of plankton. We did a plankton tow in the Gulf of Mexico. And we found a bunch of little pieces of plastic, and so these are all microscopic pieces of plastic here. Even the plankton itself you can't really see very well without the microscope, but then once you get it under the microscope, all these bright colors pop out at you, and those are the microplastics that I'm going to be talking about today. But I'm also going to talk about marine debris in general, because microplastics are just one part of the larger picture. And so the United States has an official definition of marine debris, and it is any solid man-made material, either directly or indirectly, intentionally or unintentionally disposed of or abandoned into the marine environment or the Great Lakes. And so that's kind of our starting point. And the really important part here is that it is a solid man-made material, so we don't count oil or chemicals under marine debris. Those are completely separate pollution issues. And marine debris can come in many different shapes, sizes, materials, from the tiny little microplastics that I was showing you pictures of. These can be found in your body wash, facial scrubs. They're these little tiny beads. If anybody's ever used Crest toothpaste with the little blue dots in it, those are plastic beads. And this is actually from the toothpaste that I used to use. You can also have fishing gear end up being marine debris, whether it's fishing line, nets. You can see all of these crab pots here from a cleanup in Louisiana. Boats, vessels, cargo ships, the containers off of cargo ships often get swept overboard. Those end up being marine debris. And so marine debris is just, there's lots of different angles to it and lots of different types of it. And there's also lots of different sources of marine debris. We usually break them up into 2 general categories, either ocean-based debris or land-based debris. Your ocean-based debris is going to come from things like commercial and recreational fishing, offshore oil and gas. I always thought that offshore oil and gas would be a really big contributor to marine debris, especially in the Gulf of Mexico. If you've ever been to southern Alabama, you can see the rigs right offshore. But there's actually, because it is such an obvious vector, there's a huge amount of oversight, and anything on a rig actually has to be labeled with the rig number, and it has to be permanently labeled. So it has to be either marked in marker, so even like if they take a case of water onto the rig, each individual bottle in that case has to be marked with the rig number. So if something goes overboard from a rig and somebody finds it washed up on shore, they're going to know exactly where it comes from if it gets reported, then they get fined. So they're not contributing nearly as much as I would have guessed they were. So we can stop blaming them. Also, cargo ships, like I mentioned, abandoned and derelict vessels. This is a big problem. It's expensive to get rid of a boat once it's no longer useful anymore. So a lot of times people will just scratch off the hull number and dump it. And then the last one there for ocean-based is research equipment, which as a scientist embarrasses me. And then there's lots of land-based sources, which are probably the ones that you guys are more familiar with. So littering, whether it's intentional or accidental, illegal dumping, poor waste management practices by the town or the city, stormwater discharge. So a lot of time, stormwater grates, when it rains, all of the trash that's in the street washes out into the stormwater, and there's no mechanism to catch that trash before it dumps into the creek or the stream that is eventually going to go to the river, which eventually goes to the bay, which eventually goes to the ocean. And then that last one for land-based is extreme weather events, which you guys are all very familiar with down here. We've got hurricanes, we've got tornadoes, tsunamis are a big one, which luckily we don't ever have to deal with. But all of these things create, especially the emergency ones, create enormous amounts of marine debris. So types of marine debris, we've already said that there are tons of them. This is just a graphic. So last Saturday was the International Coastal Cleanup. I don't know if any of you guys had the chance to participate in that, but they hold it every year in September. It's a worldwide thing. There's lots of places along the Gulf Coast that participate. And this is just to give you an idea of the kinds of trash that they find most often along the shoreline. And so on this side we have internationally, and on the right side here we just have for the Gulf Coast. And so you can see for both of those, the number one item is cigarette butts. Lots of people that smoke, you finish your cigarette, you toss it out the window, you toss it on the street. And most of those people that are doing that don't realize that the filter in the cigarette butt is actually made out of plastic fiber. So it's never going to break down, even though the outside of the cigarette is paper and there's tobacco in there. The filter itself is made out of plastic. And the other major thing that you can take from this is that 8 out of 10 of the top 10 items are made out of plastics.
Ben.
Excuse me. Mr. McGuire.
Ben.
Mr. McGuire.
Come with me for a minute. I want to talk to you. Excuse us, Joanne.
Of course.
Please. Thank you.
Oh, he is
Congratulations,
such a
I look at him and I can't believe it.
I know
I simply can't believe it.
I just want to say one word to you. Just one word.
Yes, sir.
Are you listening?
Yes, I am.
Plastics.
Exactly how do you mean?
There's a great future in plastics. Think about it. Will you think about it?
Yes, I will.
Enough said. That's a deal.
I'm sure most of you were not alive when that movie came out. I wasn't alive when that movie came out. But in 1967, when The Graduate came out, plastics were the new hot thing. And so it's shocking that great was such a huge understatement, because plastics are in every part of our lives. Since World War II, the production and use of plastics has increased dramatically, and they're part of our everyday life. They can be found in food wrappers, beverage containers, toys, our cars, cosmetics. They're everywhere throughout our homes, at school. And the ubiquitous nature of plastics in our everyday lives really makes them go essentially unnoticed, unrecognized, and sometimes even forgotten about. And so this is exactly why we all need to start thinking about them more deliberately. So in 2015, it was estimated that 320 million metric tons of plastic was produced, and much of that was used for single-use purposes. Rather than it being recycled or incinerated, a lot of it is either mismanaged or ends up in a landfill. So even though plastic pollution was first discovered as an issue, in 1976, the problem with plastic pollution was first brought up into the limelight in 1997 by Captain Charles Moore, who was the first person to really popularize and photograph the Great Pacific Garbage Patch. Plastics are the most common form of marine debris around the globe, including in the Gulf of Mexico. where they average between 63 and 98% of all marine debris. Likely this is because plastics are so durable. So that's why we use them. That's why we make so much stuff out of them. It's because they're durable and they have a long life and they don't break down easily. That's also what makes them an issue when they get into the environment. And so plastics will never biodegrade. Instead, they do something called photodegrading. And so that means that they'll break down into smaller and smaller pieces, but they'll never return to their base chemical components. The threat to marine life from our plastic pollution has been described in the popular media a lot lately. I'm sure you've seen videos of sea turtles with straws in their nose, and the whale in Asia that had, I think it was like 35 plastic bags in its stomach or something like that. Unfortunately, it doesn't get a lot of leverage in the public health system because we still don't have a very good grasp or idea of how these plastics that are in our environment so prevalently are impacting humans. So recently the discovery of microplastics has raised concerns among scientists, and microplastics are defined as tiny plastic pieces that are measuring less than 5 millimeters in size. And so 5 millimeters, just to give you an idea, is about the size of your pencil eraser on the end of your pencil. So they're very tiny, and then they go all the way down into the microscopic range where you can't even see them with the naked eye. Microplastics make up 94% of the estimated 1.8 trillion pieces of plastic that are floating around in the Great Pacific Garbage Patch. And that's just one small area of plastic. There's plastic everywhere across the globe. And it's important to realize that microplastics are broken into two separate categories: primary microplastics and secondary microplastics. The primary microplastics enter the environment. They are actually manufactured to be that size, and are often found in items like cosmetics and personal care products, like I was talking about before, your face wash, your body wash, your toothpaste. A lot of times makeups will use tiny plastic beads as fillers in wrinkle creams and foundations. Secondary microplastics enter the environment through fragmentation and degradation, and so this is the breaking down of larger plastic products, whether it's a plastic bottle or a plastic bag, and those get broken down after they're exposed to UV light from the sun, freezing and heating cycles, and then also wind and wave action and abrasion. Another important source of secondary microplastic pollution occurs from the breakdown of synthetic fibers. So probably most of you are wearing a synthetic fiber if you own fleece or nylon, or any of those garments that are like supposed to wick the sweat away from you. All of those are synthetic fibers, and as you're wearing them, they shed particles, and then when you throw them in the washing machine, obviously, if you've ever cleaned out the lint trap in your dryer, you know it's shedding during the wash cycle. And so since 2016, we've been working with NOAA Fisheries to sample for microplastics during their annual CMAP plankton sampling. And so it works out really well with plankton sampling. I showed you the pictures at the very beginning. The products that you use to sample from plankton are also the exact same ones that you use to sample for microplastics because they're the exact same size. So it works out really well to just tag along with them when they do their sampling and collect extra samples to look for microplastics. So every September they do this plankton sampling, and they run the entire continental shelf from Brownsville, Texas, all the way over to the Florida Keys. They're actually out there right now sampling. Unfortunately, I didn't get to go along this year, which is a bummer. And they'll get back on September 30th, and then we'll have a whole lot more data to look through. And so during this sampling, we have 3 different sampling methods that we use. The first one is using a Newston net tow, and so this picture right here is what the Newston looks like. And so it's 3 meters wide by 1 meter tall, and you drag it along the surface, and it collects huge volumes of water that filter through the net that you can sort of see back here, and it catches everything that's in the water column that's smaller than the mesh size of the net. And so we do 10-minute tows with that, and it allows us to sample huge volumes of water to look for microplastic content. And this is an example of one of the sieves. This is one of the more obvious ones. So there's a piece of plastic, there's a piece of plastic, there's a piece of plastic. Usually the plastics are much smaller than that and a lot harder to see. The second method that we use is called a bongo net. And so a bongo net is used to sample the entire water column. And so you start at the surface of the water and you let the line out and the net goes all the way down through the water column to the bottom and then you pull it back up. So you're getting the entire water column sampled. And it's actually two separate nets here. And then all of the microplastics, the water filters through this net, and down here that you can't see, there's a capture area down here that collects everything that gets caught in that net. And that's me. And you get to use a fire hose to rinse the net out, which was super fun. And then the third method that we use to collect is actually whole water samples. So we drop what's called a Niskin bottle down over the side and collect a whole water sample. So this one collects 5 liters of water at a time. And then we split those into 1 liter containers, which we then run through a filter. And this allows us to catch those really tiny microplastics that we can't catch with a tow because the mesh size for the tow nets is way too big. And then this is just an example of the filtering system that we use. So from the samples that we have so far, I think I've sampled 37 stations in 2016 and 2017. And then this year, while they're out right now, we have somebody on the entire trip for the entire month. So we're going to get 57 more stations sampled this year in addition to the ones we already have, which is awesome because more data is better data. And so this is looking at that first one that I was talking about, the Newston one that just drags the surface. And you can see here these yellow dots are the stations. There's really no rhyme or reason to why concentrations are higher in some places and lower in some. There's no correlation that I could find to which state you were offshore of or how high the population was. And the Gulf-wide average was just less than 1 microplastic per cubic meter. And I don't know if cubic meter really makes much sense to you, but this is about 2 meters wide. So have that and make it a box. And so those were our Newston samples, and you can see this is the mesh size, so it's about half a millimeter mesh size. And then this is the graph for the bongo tows, which are the ones that do the whole water column. You can see that this mesh size is smaller, so we're actually able to catch more of the microplastics in that one because it has a smaller mesh. And we see that in our Gulf-wide average because now our Gulf-wide average is about 2.5 microplastic per cubic meter. And so that's just telling us that there are a lot of smaller microplastics that maybe people are missing that are definitely contributing to the whole microplastics problem. And we definitely found much higher concentrations of microplastics over here off Florida. I don't know why. And much lower concentrations off Louisiana. I will say Louisiana only had 5 stations sampled, so we need to get more data from there, but because I would expect with the Mississippi River coming down and draining here that there would be a lot. And then the third one is those whole water samples, which were the ones that we ran through the filters. We didn't really find any correlation with where they are related to population centers or runoff even, but we do see a correlation with the concentrations and the surface currents, as well as the sediment transport system. So microplastics are moving through the water column very much like sediments are, which makes sense because they're very similar in size as far as particles go. So the Gulf-wide average for the whole water samples, which if you remember is the one that catches the entire spectrum because we're using the little tiny filters to catch the little tiny stuff and the larger stuff. And so the Gulf-wide average for that is 7 microplastics per liter. And so this is just shy of a liter. And so there would be 7 microplastics in this if I had taken this sample off a boat in the middle of the ocean. And then looking at the types of microplastics, because that's really the important part. So we know how many microplastics are out there, but what kind are they, so that we can kind of figure out where they're coming from. And so overwhelmingly, the most dominant type of microplastic that we found were fibers. They made up between 62 and 72% of all the microplastics that we found. And those are most likely shed from those synthetic fabrics that I was talking about earlier. And then they're released as you're wearing them or through the wash. Those were followed by lines, which would come from ropes or nets, and then fragments, which, as I said before, break down from your larger plastic items. Very, very rarely did we find microbeads, foam, or pieces of film for microplastics. So, in case you have not caught on yet, microplastics are everywhere. They have found them obviously in the Gulf of Mexico. You can find them in Antarctica. They found them in the Himalayas, on the top of Mount Everest. You can literally find microplastics anywhere you bother to look for them. And so I'm going to talk a little bit about the items that we are eating that people have bothered to look at that contain microplastics. So they have been found in all different types of marine life, table salt, sea salt, honey, sugar, beer. They're in the dust in our houses, and most alarmingly perhaps in our bottled and tap water that we're drinking. So if you used one of the plastic bottles that they were giving out at lunchtime here, you're probably drinking microplastics right now. So microplastics create problems in several ways. So first and most obviously are physical impacts from ingesting microplastics. They can cause harm to marine life by accumulating in their gills or their digestive systems. If you accumulate enough in your digestive system and you're small enough, then those microplastics could prevent you from eating, leading to starvation and eventually death. There's also plasticizers in microplastics. The plasticizers are a chemical that make the plastics so useful and so durable, but they're also toxic. And those plasticizers have been linked to abnormal growth and reproductive problems in multiple animal models. They also have been studies showing that organic pollutants like pesticides will adhere to the plastics as they're floating through the water. And then when something eats those plastics, it's possible that those pesticides are leaching from the plastics into the tissue of that organism. And last, just this year, there was a study that was published that shows that heavy metals like lead and cadmium will absorb into the plastics as well, and then those can be transported to places that we otherwise wouldn't find high concentrations of them. So this is the downer side of the talk. So I'm going to start with salt. And so there's been a couple studies looking at salts. The one is looking at table salt. And so this is the kind of salt you're probably using. It's the one that has iodine in it that you buy at the grocery store. This study looked at 17 different brands of table salt from 8 different countries. And they found between 1 and 10 microplastics per kilogram, which sounds high, but then you have to think about what a kilogram is, and that is like a lot of salt. You probably don't eat a kilogram of salt in a year unless you really like salty food. So if you follow, on the next couple of slides, it's gonna be how many, each of them will have this red box that says how much, if you eat the recommended dose for the average adult, how many microplastics are you actually consuming per year from that product. And so with table salt, you are eating a whopping 37 microplastics per year. So not really something we need to worry about yet. On the other hand, sea salts have higher concentrations of microplastics in them, which makes sense. There's lots of microplastics in the ocean. Sea salt comes from seawater. So if you are using sea salt, then you are probably consuming more microplastics than you would if you were just using table salt. But again, that only comes out to 180 microplastics per year if you're following normal salt guidelines. And this picture down here just gives you an idea of some of the types of microplastics. So these are both examples of fibers. And they actually, fibers were the second most abundant microplastic they found. Fragments of plastic were actually the #1 item that they found in the salt. It can also be found in honey. Don't ask me how it gets in the honey. I have no idea. It didn't say, they didn't speculate on it in the paper. But they looked at 19 different sources of honey from 5 different countries. And they found, on average, 166 microplastics per kilogram of honey. And so if you eat honey, be aware somehow the bees, I don't know if it's the bees eating honey and then regurgitating it into the honey, or not eating honey, but eating microplastics and regurgitating it, or if it's something in the refining process of the honey when they package it that you end up with microplastics in it. But they're there because somebody bothered to look for them. And then the other one that kind of goes along with honey is sugar. And so they looked at 5 different brands of sugar. Refined sugar had a lot fewer microplastics in it than the unrefined sugar does, which makes sense because refined sugar is processed and bleached and cleaned and filtered. Unrefined sugar is not. And so if you consume the average recommended dosage of sugar for an adult, you could be eating between 3,000 and 121,000 microplastics per year. And so those numbers are a little bit larger than the ones we've seen so far. And then beer, which is obviously an important one for a college kid. You guys probably drink more than 1 beer per day, so you'll have to scale that up. The first one looked just at brands of beer from Germany, and they found on average 22 microplastics per liter. So if you drink 1 beer a day, then you're consuming about 3,000 microplastics a year. The other one is a little bit more relevant to us. So they sampled 12 brands of beer that were bottled in the Great Lakes region. Unfortunately, nowhere in their paper do they say which beers they were, so I can't tell you that. But they found on average 4 microplastics per beer, so a lot lower than the German beers, so stick with American beer. And probably the most likely way that those microplastics are getting into the beer is through the beer brewing process. And so you have to use water to make beer, and you find a lot of microplastics in water. So the first study looked at bottled water, and they looked at 11 different brands of bottled water from 9 different countries, and they didn't find microplastics in every sample that they ran. But on average, they found 325 microplastics per liter in bottled water. And they actually found that most of those microplastics came from the bottle the water was in itself. When we look at tap water, the other study they found microplastics in 81% of the 159 taps that they sampled across 14 countries. With an average of 5.5 microplastics per liter, so way less than they were finding in the bottled water, which makes sense if the microplastics in the bottled water is coming from the bottle itself. They also found that less developed countries had fewer plastics in their tap water than the developed countries do, which makes sense because if you're in America, you have unlimited access to plastic products and plastic clothing and synthetic clothing, and a lot of times in developed areas you have a lot less access to those things, so they would be less prevalent in the environment and in the water. Unfortunately, microplastics are also found in the air, so they've been detected in the atmosphere, in dust, both indoors and outdoors in the air, and then also even in human lung biopsies. One thing that surprised me, but probably shouldn't have, is that indoor air has higher microplastic concentrations than outdoor air does, which makes sense because we spend most of our time in indoor spaces. It's a confined space, and oftentimes we recycle the air in it. And so indoor air had between 3 and 60 microplastics per cubic meter, whereas outdoor air had between 0 and 1.5. Definitely a huge difference there. And something that I don't really know what we can do about other than maybe using smaller size filters on our AC units or our HVAC systems. But definitely something to be aware of. Like I said, microplastics are everywhere. And they're also in our seafood. So being that you all live in Alabama, I'm sure you eat lots of Gulf Coast seafood. Microplastics have been found in all different types of shellfish, so oysters, clams, mussels, all of them have been found to have microplastics in them. Luckily, not all of them have microplastics, like not all of the individuals in that organism have microplastics in them, but they've been found in all of those organisms. There's also lots of different species of fish and fish larvae that have been tested for microplastics. Some of those are commercial species that you and I would eat. Usually when they're looking at fish, though, they're not looking at the tissue, they're looking at the stomach or the digestive tract. And obviously when we eat fish, we're not eating the fish stomach, we're eating the tissue or the muscle. And there haven't been many studies that have actually looked at the tissue or the muscle of the fish to see if the microplastics are getting from their digestive system into the tissues, which is the part we would actually consume. But with shellfish, we eat the whole thing. So if there's microplastics in the shellfish and we eat the shellfish, we're eating them. They've also found microplastics in squid, if anybody eats that, and then various species of crustaceans, including crabs and lobster. But again, those ones we're looking at the digestive tract, so we don't know if it's in the tissue. So maybe we're not eating them when we eat crab and lobster. The good news that I have for you is that 99% of the microplastics that you ingest actually pass straight through the human body. So you can look back at all those numbers that I threw at you in the last 10 minutes, calculate how many microplastics you're eating in a year, figure out what 1% of that is, and that's how much is staying in your body. And that's just the stuff you're eating. We're not counting the stuff that you could be breathing in. So that's your good news for the day. So making it a little bit, drawing it back to the Gulf Coast, I've been doing some research on the eastern oyster, which is the kind of oyster that we have offshore in Alabama. And so I did a bunch of different studies looking at microplastics, if oysters were consuming them, and if they were, how did they affect their growth, their respiration, their ability to filter, and then also was it causing oxidative stress to them. And so I looked at two different types of microplastics, polyethylene, which is usually used to make hard plastics, and then polystyrene, which is your styrofoam plastic. And then had different concentrations and treatments. So we had a high concentration and a low concentration, and then ones that mixed the two types of macroplastics together, so they were being exposed to both of them at the same time. And so there was a whole lot of graphs and data about that, but I'm only going to show you one of them. And this is just looking at looking at the number of microplastics in the oysters. And so other studies that have looked at different species of oysters around the world have found between 0.5 and 57 microplastics per oyster. And that's not in every oyster again. The research that I did, the oysters that we grew in the laboratory that we intentionally exposed to microplastics, 96% of them contained microplastics. Luckily, my control group over here contained significantly fewer than all the rest of the treatments, which is good. Unfortunately, they did still have microplastics in a couple of them, but they were fibers, and I think it was from my clothing, and it was in the air, and it got in the tank. So if I ever do this again, I learned a valuable lesson. And then I also collected oysters from some of the aquaculture growers in Mobile Bay and Mississippi Sound. And the good news is that those oysters, only 25% of those had microplastics in them. And they only had between 3 and 5 microplastics each. So much lower numbers than other people are seeing. And good news for Gulf Coast oysters.
Now we can just get the sewage out of the water.
I know. Baby steps. So we've talked about a lot of different exposure pathways for humans. There's 275 million tons of plastic waste produced. So this is just plastic waste. It's not all of the plastics produced. It's just the ones that are thrown away every year. About 8 million tons of those end up in the ocean every year, or in the water itself. It doesn't have to be the ocean. Eventually it's going to end up in the ocean, but it could start out in a creek or a stream or a lake, which you guys all have around here. And then those microplastics can end up, like I said before, in salt, in water that we drink, in our beer, in our seafood. And then there's also the land-based side of things. So if landfills are mismanaged, or we have litter or illegal dumping, those plastics can get into the soil. If you use irrigation, the microplastics can get into the soil and the food that we're growing that way. And I'm going to assume that's how they end up in sugar and honey, but again, I'm not certain on that, so don't quote me on that one. And then we also have microplastics that are in the air, which we can be inhaling. So there's still lots of things that we don't know. So we don't know if inhaled particles are lodging in our airways. I did say that there was a study that found microplastics in human lung biopsies, but that was just kind of an afterthought. It wasn't the purpose of the research. It was just something they noted. So we don't know what's going on there yet. Feel free to take that on. We don't know if inhaled or ingested particles are causing a chemical or physical harm to us. We don't know if they are causing inflammation. We don't know if they are delivering toxic chemicals or heavy metals or other pollutants into our bodies. And we don't know if they alter our metabolism or increase our oxidative stress. And we don't know if they have any specific implications for developing fetuses or children. So obviously there are still a lot more questions out there that need to be answered than we have answers, especially when it comes to how microplastics are impacting humans. The long-term impact of microplastics on human health is largely unknown, because most of the studies to date have focused on marine life that's directly consuming microplastics versus us who are consuming them secondarily. It is clear that humans are exposed to these particles, obviously, through the food that we eat and the air that we breathe, but we don't know what those damaging impacts, or if they're having any damaging impacts on us. Maybe it's just one more thing we're exposed to that our body deals with naturally. But it would be an unnatural thing it's dealing with naturally. So the wide distribution of marine pollution throughout our environment, we create more and more of this in our daily lives with our daily activities, and there are a variety of routes through which humans are exposed to these microplastics. As Rachel Carson wrote in the Silent Spring book that I'm sure you all had to read at some point, if we are going to live so intimately with these chemicals, eating and drinking them, taking them into the very marrow of our bones, we had better know something about their nature and their power. And I'll leave you with that. So thank you guys so much for coming and spending your lunch hour with me. I really appreciate it.